Hello guys, welcome to the second puzzle in the playlist. This is the playlist that is specially made for interview puzzles. You can find all the important and interesting puzzles in this playlist. So, follow the entire playlist and be interview ready as well as train your brain. Now, if at any puzzle, if you are able to solve it on your own, then it's fine. But if you are unable to solve it on your own, you no need to worry, because I will promise you that you will get clear and crisp solution to every puzzle that is there. So please follow this entire playlist and watch the video till the end to clearly understand what it is. Let's start into the second puzzle in this playlist, which is calculating total distance covered by the bee. Now let's see the problem statement. So in this problem, there are two trains which are moving towards each other, and they are at a distance of 100 kilometers initially. The speeds of the trains are 70 kmph and 50 kmph. And with those two trains, there is one bee which is traveling at a speed of 80 kmph as shown here. So what does that bee do is it goes towards the train 2 and it comes back again. So it kind of does to and fro kind of motion. It goes to train A, let's say this is A, let's say this is B. It goes towards train A and then it comes towards train B. So basically, say at instance 1, if train A is this is if train B is this, it will be B will be here. From here it will try to go somewhere here. By this time this train 2 will come here. So after reaching here only, the B will return back its journey to meet train A, but by the time B is traveling this whole distance, this train A will come here. So in this way, if this is one instance, uh, the two trains will move towards each other. So the B will, from here to here, the B will try to reach this position, but by this time only this train 2 will move here, so it will return its track at a position earlier than it is expected, right? So we expect it will return at train B, but when the B is coming in this direction, the train would have traveled some distance, so the B will return its journey somewhere here, not at the start position of B. So this kind of becomes a tricky problem because of this reason, because the trains are moving. So if the trains are not moving, we can simply solve this. But the trains are moving here, and the B will change its direction every time it meets the train. For example, if the B is traveling in this direction, and if it sees the train or if it meets the train, then it reverses its direction and tries to reach A. By the time A will travel some distance, so after meeting A, this B will again return its direction and it will again reach B, and after reaching train B, it will again return its direction of reverse its direction of velocity. It will reach train A. So in this way, it keeps on moving to and fro from one direction to another direction until the two trains collide. We have to calculate what is the total distance of this path. So this seems very tricky, right? We have to calculate total distance of this path. So take 1 minute, pause the video for at least 1 minute, try the solution on your own, and let's see. If you're unable to get it, don't worry, we can discuss crisp and clear solution, and watch the video till the end. So let's see the generalized solution for this problem. So let's say the speed of train A is u kmph, and speed of train B is v kmph. Now, and the distance between them is d. Now let's first solve the question how much time it will take for the two trains to meet, how much time it will take for the two trains to meet. So you can see this distance d is will be decreasing at the speed of u from this direction, and this distance v will be diminished with the velocity v from this direction. So it is decreasing at the speed of v plus u kmph from the both directions. So it will take d by v plus u hours to collide. So it takes d by v plus u hours to collide. And if you're fine with this, let's solve the next part of the problem. So if you clearly observe, we will always, the honeybee, let's say the speed of honeybee is some x kmph. The honeybee is always in traveling state in these hours. So it must travel distance of its velocity into time. What is its velocity? X. And what is the time? D by v plus u. So for this much time, after this much time, the two trains will collide. And we know till this time, the B is always traveling. So this is the time of journey, or time of total journey. Total time taken for the journey of the B is this much. And what is the speed of the B over this entire journey? It is still x. It is maintaining uniform velocity of x kmph, even though it is changing its direction from right to left or from left to right. Even though that is happening, it still is maintaining uniform velocity to in the entire process. In this entire process, it is maintaining uniform velocity of x. For the time d by v plus u total time, it is maintaining a uniform velocity x. So the total distance traveled by this honeybee is x into d by v plus u. Now if you plug in the numbers, x is the speed of b, which is 80, and the distance is 100, and v plus u is 70 plus 50, which is 120. You will get approximately 66.7 kilometers. This is the entire path, length of the path that is covered by b, which is 66.7 kilometers. Even though we cannot say what exactly is the path, it can be like this, it can be like this, we don't know. It can be zigzag way, because it goes and reverses its direction here, and it reverses here, reverses here, reverses here, reverses here. We cannot track the entire path, but we can logically say how much distance it traveled, because it is maintaining uniform velocity x, and we know the time duration of the journey. We can say total distance traveled by that, even though we cannot trace its path. I hope you understood the solution, and please share, like and subscribe if you like this video, and also please comment what's your opinion on this video. Thanks for watching.